that you also know how to simplify it.
So would you take the cubed root of the top and the bottom?
Yes, that would be better than just putting it directly into the calculator.
Okay, so then it would be 5/3.
Yes, very good. Okay, let's look at a problem like number 2. I'll give you a couple of variations on this. Let's say it's 5 to the 2/3 power. Actually, hang on a second here. This is one of those I do think we should just do together, the one that was given. The answer, because it doesn't say to round. And so like it's almost like your instructor wants it exact. Do you know what the instructor wanted for this original one?
Yeah, I think for this one he wanted not like a decimal form, he just wanted the radical form.
Okay, yeah, that's what I was getting at, is you don't want to go right together. So you correctly wrote 5th root of 3. Now the power of 2 actually goes inside here. It can go outside, like this was correct, but it's preferred to have it sort of inside there. I would like to see the 5th root of 9, something like that.
Yeah. Yeah.
Okay, so let me have you try one here. You got that down.
Mm-hmm.
Let's go 7 to the 2/3 power. I want you to write that in root form.
So it would be the cubed root of 49.
Yes. Yeah. Okay, we can move on to number 3 now. So the original problem, 4x to the 5th equals negative 172. A really good start here. You're like, hey, I got to divide both sides by 4. So x to the 5th equals negative 43. And this is where I think maybe we haven't talked enough about this. So to undo the power of 5, you end up using a 1/5 power.
Yeah.
Okay, the way you have it written is actually a square root. So this would be preferred. I would like to see you do this. And then minus 43 also to the 1/5 power. All right, so on the left, it becomes just x. The exponents cancel.
Yeah.
On the right, you can write this as in blue. I'll just circle this in blue. We want to go into radical form. So it's the 5th root of negative 43 to the power of 1.
Mm-hmm.
And this is where you would then go to your calculator and approximate it. Okay, so your instructor is expecting everything that I'm about to highlight. They want all of this.
Yeah.
Not just the decimal form.
Right.
Because the idea is they know they can give you they know you can get the decimal form, but can you write it in this exponent form?
Mm-hmm.
So let me give you one like this to try out. 3x to the 7th equals negative 63. Go ahead and solve that for me, please.
So I got x equals negative 1.54.
Okay, what about the root form though?
It would be 7 radical negative 21.
Yes, 7th root of negative 21. Yeah, that's good. Any questions on how to like do that in the calculator, or is that totally clear?
No, I think we're good on that one.
Okay. Fantastic. Okay, so number 4, you did really well. I think it's correct. I'll make a comment about your answer that you'll have to tell me if this is something your instructor is emphasizing.
Mm-hmm.
So this answer here for number 4 is correct, but a lot of instructors want you to divide each term by the 14. It's kind of like that A plus BI stuff that we were doing in the last chapter, last unit.
Yeah.
And I only bring that up because sometimes it's a point of emphasis. Do you know if that is the case here?
I think so. This one, he kind of tried to explain, like, do it for me, and I saw the answer key, and he left it as the answer I wrote. But I was actually hoping if you could kind of reteach like the original problem to me, because I don't think I understood it as much as I wanted to.
Yeah, let's we'll have to do a little bit of a simpler problem to start out with. So let's say you were asked to rationalize the following: 8 divided by the square root of 2. So rationalizing means to get the root out of the bottom. And you do that by multiplying the top and bottom by the same root. So in the numerator, it becomes 8 square root 2. In the denominator, it's the square root of 4. But the square root of 4 is a whole number. It's 2.
Yeah.
Now you can divide 8 and 2 and get 4 square root 2.
Right.
And you might have seen that last year, maybe. Not sure. So why don't you try this one? How about you try 12 over the square root of 3? What would you multiply the top and bottom by?
Square root of 3.
Square root of 3. Yeah, whatever's on the bottom, you multiply by. So the numerator becomes 12 square root 3, and the denominator becomes the square root of 9. And so you write 12 square root 3 over 3, and then you can divide the coefficients. You can divide these.
Right.
And you get 4 square root 3.
Yeah.
Okay, so that kind of leads into being able to do the problem that you were asked to do. We're going to do a little bit of a simpler one to start out. So let's say you were asked to rationalize 1 over 1 minus square root of 2. So this time you cannot just multiply by the square root of 2. You actually have to multiply what's called the conjugate. And the conjugate in this problem, all you do is change this sign. So it becomes 1 plus the square root of 2. Did you hear that word today, conjugate?
Yeah.
Okay. So it doesn't mean much, but it's the same thing, but you change the operator in the middle. If it's minus, it becomes plus. If it's plus, it becomes minus.
Okay.
So the numerator is not bad at all. It's just like, all right, take 1 and multiply by each of those. It's 1 plus square root of 2. On the bottom, you have to FOIL.
Right.
Okay. And you'll see something every time you do this, but it's good to FOIL. So the FOIL starts out as 1 times 1, 1 times the square root of 2. The inner is minus square root of 2 times 1, so minus square root of 2. And then the last is minus square root of 2 times the square root of 2 minus the square root of 4. Please look that over and see if that's clear, because I'm going to have you FOIL one next.
Okay, yeah, that makes sense.
So you notice that the outer and the inner cancel, and that is always the case.
Yeah.
The square root of 4 is a number, so this is really 1 minus 2. So the bottom, the whole point of the conjugate by multiplying by the conjugate is that the bottom is now a number. It's a nice number now. It's friendly.
Mm-hmm.
So it ends up being minus 1 on the bottom. So I kind of rounded. Let me move this over here. Conjugate over here. So this becomes 1 plus square root of 2 over negative 1.
Mm-hmm.
And then you're really supposed to divide each of these by negative 1. So it's really 1 over negative 1 plus square root of 2 over negative 1, which ends up being minus 1 minus square root of 2.
That final or the final numbers you got, is that from like the numerator and the denominator? You just multiplied it?
Yeah, so there's really a 1 up here next to the square root of 2.
Mm-hmm.
So 1 over negative 1 is negative 1, and similarly 1 over negative 1 is that.
Mm-hmm. Okay.
Okay, so let me have you look at another one here. Did you get all this down?
Yes.
Or get it, I mean, get it later. Okay, let's say it's 1 over 4 minus the square root of 3. First thing you have to be able to identify is the conjugate. The conjugate in this problem is 4 plus the square root of 3. The conjugate is always just changing the sign in the middle. So if this were like negative 4, it would still be negative 4. The minus is what changes.
Yeah.
All right, and so what I'd like you to try doing is foiling the bottom. I want you to multiply out the 4 minus the square root of 3, 4 plus the square root of 3.
Okay. So I got 13.
Yes, it becomes 16 minus 3, which is 13. Very good. So in the numerator, it's 4 plus square root of 3 over 13. And this maybe is okay, but it's not, let me go back and look at your problem. Yeah, it's not really preferred, but I guess that's okay. So let's try another one here. This is an important skill to have. Let's say it's a negative 2 over negative 3 minus square root of 2. Can you tell me what the conjugate is when you're rationalizing the bottom?
It would be 3 plus square root of 2.
It's only the middle operator that changes.
So it's still negative 3.
Yeah, it's really important. Just this middle one changes.
Okay. So that would be 6 minus the radical 4 on top.
So you distribute it, and we haven't done this yet. I'll do it in steps here. I'll write it out, and then we do need to FOIL the bottom, but the top we can do first. So you're multiplying that negative 2 into both, but there's really a 1 in front of the square root of 2. You cannot multiply into the root. So it becomes 6 minus 2 square root 2. Minus 2 times minus 3 is 6. Minus 2 times 1 is the minus 2 square root 2.
Yeah.
Will you FOIL the bottom for us, please?
Yeah. I got 7.
Yes, 9 minus 2 are 7, and we can consider that done. Okay, so let me give you one to try on your own, if that's okay. 5 over
I
Okay.
actually know the question on that one.
Oh, so go ahead.
So since it's 6 minus 2 radical 2, do you keep it like that, or would you subtract it and make it 4?
So the order of operations says you're really multiplying the 2 times the root 2
Okay.
first, and they're not like terms. Like 6 does
Yeah.
not have a root 2 with it, so it's not a like term. So another thing that I guess I failed to mention, I'll show you now. I'll talk about it now. Let's say I give you a problem like this. If the order is different than what you expect, you still only change the sign in the middle, the operator in the middle. So the conjugate would be square root of 5 plus 2, square root of 5 plus 2. So notice in this new problem, it's not number and then square root, it's square root and then number. You only change the operator in the middle.
Okay.
So I'd like you to try working this one out for us, please.
So would it be, okay, so it's radical 25 minus 4, and then 5 minus 4, which is 1.
Are you talking about the top or the bottom?
I foiled the bottom first.
Okay, so the bottom becomes 5 minus 4,
Yeah.
which is 1.
Mhm.
So the foiling is a little different, but it ends up being the square root of 25 plus 2 square root 5 minus 2 square root 5 minus 4.
Yeah.
I know it was different order. It's still a foil. It's still the first outer inner last.
Okay. So then the top would be 5 square root of 5
Okay, plus.
plus 10.
Yeah. Okay, this last one you probably will not be seeing on your exam. So let's continue forward with this one. Well, let's continue to number 5 just to make sure we get through as much as this. So a lot of this is like kind of new from what we've been doing. Maybe are you finally kind of caught up in class? Oh, you're out for a little bit.
Yes, yeah.
Okay. Yeah. But we haven't done much on this stuff, so it could be more difficult. So the problem here, what I would recommend doing is writing it in exponent form first. So 3 over 4 like this. Is that clear how I did that? Okay.
Yeah.
Now, here's your goal. You want to have just an X on the bottom.
Okay.
Okay, just an X. And the reason you don't just multiply it by this is because it's not a square root. The thing we just did only works for square roots. So you want an X to the power of 1, but 1 is really 4 divided by 4. So what do you multiply X to the 3/4 by so that when you add the exponents, you get 4 over 4. So what I'm really asking you is what is 3/4 plus some number equals 4/4? What is that number?
1/4.
1/4. And that's what goes here.
Okay.
This is not how you probably saw it in class, but I do believe this is more effective. as a student
Yeah.
to learn. Okay, now in the numerator, it becomes 2x to the 1/4, but in the denominator, you're adding the exponents, 3/4 and 1/4, so that makes 1. So it's x, it's really x to the 1 on the bottom.
Right.
And then in the top, you have to rewrite x to the 1/4 as the 4th root of x, like this. So let's do another example and see if you can make some headway on this. All right. So here's another problem. You might see 5 over the cube root of x, and it will say to rationalize. So what I would do is I would write the bottom as x to some exponent. Can you tell me what that exponent is from this root?
Would it be 1/3?
Yeah, it's 1/3. Perfect. Okay. Now our goal is to get it to x to the power of 1, which is really 3 over 3. So you use the same denominator. So you can write it off to the side if you want, but it's like 1/3 plus something gets you to 3/3. That's the goal.
Yeah. So it would be 2/3.
2/3. So this is x to the 2/3 power, x to the 2/3 power, just like you said.
Then it would be x on the bottom.
Becomes just x on the bottom, yep.
And then it would be 5, and then the radical with the cubed root of x squared.
Yes.
Okay.
Let me give you one to try here on your own. Okay, go ahead and rationalize this for me, please.
So the one on the outside of the radical is the one that's the denominator, right?
Yes,
The
the
5
5 goes on the bottom, yes.
Okay. So it would be 3 radical x to the or 5 radical x, and then cubed.
Okay, over
X.
Yeah, that's perfect. Okay, so small little wrinkle, like I don't know what your instructor would give you. Let's just say there was a 2 on the bottom here. You ignore it, but it comes with your answer, but you only focus on the radical.
Yeah.
All right, so let's move to another topic here. Number 6. So I just looked ahead. I guess we did do a lot of the stuff that's after like question 7 or 8. So that's refreshing. I was wondering what you was wondering how I was like, wow, she's not going to do well in this, but you actually have seen a lot of this. This is the only stuff you haven't seen that we've worked on.
Yeah.
Okay, so this one, I know you've already got the answer down, but I wanted to give a little I don't know, Matthew's, spin on it, so in case this
is
unclear.
Because this one was a little bit like, I get how you just have to simplify it, but I think the way I simplified it, it just kind of got confusing.
Yeah, so we're going to break this up. This is the cube root of -8 times the cube root of n to the fourth. That's the first thing we're going to do. All right, so the cube root of -8, that becomes -2. I don't think there's any questions on that.
Yeah.
But this next one there is. Now, this is another rule, but when this number outside is smaller than the one in here, you're going to be able to bring one out. But rather than do it that way, I'm going to show you it visually. This is the cube root of n cubed times n to the 1. And then you can break that apart into the cube root of n cubed times the cube root of n to the 1. So that n to the fourth, you break apart into 3 and 1 because that's a 3 up there.
Mm-hmm.
And then you further break them apart into where the 3's match and this one does not match.
Yeah.
The reason you do that is because this one that I'm circling here becomes just n.
Okay.
So the next part of this is maybe more clear, but you can combine these because they're like terms. They have the same cube root of n on both of them.
Yeah.
And that's why it becomes 4n cube root of n. Okay, so let's try another one here. Just the first part, because that's the one that I'm sure is unclear. Let's say it's the cube root of -27 x to the fifth. And that's all it is for the moment. So you break this apart into it's the cube root of -27 times the cube root of x to the fifth.
Yeah.
What is the one on the left? What is the cube root of -27?
-3.
-3, good. Now the one on the right, I mentioned this previous problem, this 3 is smaller than the 5. So you break the 5 into a 3 and then anything else that's left over. So it's the cube root of x cubed times x squared, because the 3 and the 2 add up to the 5. And then you break this apart into the cube root of x cubed times the cube root of x squared.
Yeah.
What about this is not clear?
I get the first part where it's like the cube root of a simple number like that, but then so you still take the cubed root, but then it's x cubed again because you have to add up to the number it was
Yes.
originally. Okay.
I'll give you another option here after we do this problem, but I wanted to see if this took hold. So the cube root of x cubed, this middle one becomes just x, like this, squared. So let's say the original problem also said minus 4x cube root of x squared, and you bring that all the way down here. Can you tell me what the result is now when you combine like terms?
It'd be -7x, and then
Cube root of x.
X squared.
Okay, let me try and do this a different way and see if this helps. You can tell me if you like this. This is an alternate approach. This is the one I use, but it's not for everyone. So let's just say you're asked to find the cube root of n to the fourth. And you first wrote this as a fraction. Is that okay? That's just moving the exponents around?
Yeah.
Now you have not done this in a while, but 4 divided by 3 is 1 with a remainder of 1.
Mm-hmm.
Okay, now you're like, why is he doing that? This is why. These two numbers we use in the new form. So n goes on the outside. This first one becomes its exponent. cube root of n, the second one becomes the second exponent.
Okay.
Okay, so let's try it for the one we just did now. Let's do the cube root of x to the fifth, which is really x to the 5/3 power. 5 divided by 3 is 1 with a remainder of 2. Is that okay? That part?
Yeah.
Okay. So your answer is x cube root x. This first one goes here on the outside with the 1. This 2 goes on the inside here. There.
Okay.
So
Can
now
you
that, go
can
ahead.
you do that one on the problem that was on my paper? Like do the same way.
Yes, that's why I'm showing you this.
Yeah.
Yes. So like the answer to the first one was n cube root n. If you go look at your problem, it was n cube root n, and that -2 came down.
Mm-hmm.
And then the x to the fifth, the cube root of x to the fifth became x cube root x squared, which is exactly what this is right here.
Yeah.
Let's try another one here. See if we can get you to see if this is better. So let's say, and I'm going to change it up a little. Let's say it's the fourth root of 16 x to the 9th. Actually, your instructor might not do that. Let's go 7. Let's go 7. Okay. So this breaks apart into the fourth root of 16 times the fourth root of x to the 7th. What is the fourth root of 16?
2.
2. This fourth root of x to the 7th is x to the 7 over 4. 7 divided by 4 is 1 with a remainder of 3.
Mm-hmm.
It's the x fourth root of x, but you have to put each of these numbers. Let me color code them. Maybe that'll be easier. 1, the 1 goes there. And then the 3 goes there.
Yeah. And then how do you like make it into more simple terms? I think that's
I mean, that's it. It's the end result here is 2x fourth root of x cubed.
okay.
But there would be something paired with it, like over here, that we would subtract.
Yeah.
Let me give you one to try here. All right, let's go fourth root of 81 x to the 6th. Could you try reducing that, please?
Then you use the fourth root of 81, which is 3.
Okay.
And then you do 6 divided by 4, so it's 1 remainder 2.
That's right.
So then you take x to the 1, and then the fourth root of x to the 2.
X squared, yeah. So if this were minus, 9x fourth root of x squared, you could then combine like terms.
Yeah. Okay, that makes more sense.
Okay. I wish we had done these earlier because there's so many other kind of examples that could give, but is it okay if we move on to 7?
Yes.
Okay. All right, the graph given is the graph of g of x. The parent function for g of x is the cube root of x. Cube root of x. So you're supposed to know there's like 10 parent functions. You're supposed to know all of them. I mean, I understand if you don't, it's a lot to remember. You have to remember though, like where this point is supposed to be. And it's supposed to be back here at the origin. So it's kind of like a vertex in the sense that it's like this. It's not really a vertex, but it's the point that kind of like helps you figure out where it's been shifted.
Right.
Okay, so to me, this one's been shifted 2 to the right, and I would actually write this right 2 and up. I'm sorry, right 1 and up 2. I missed the scaling.
Wait, how did you figure that out?
Every box is half, not 1. So this middle point here is at 1 comma 2, and that means it's been moved right 1 up 2 from where it's supposed to be.
Oh, yeah. Okay.
It's a little bit hard here, but it's like I almost just have to give this to you. It's x minus h plus k, where this is your h and your k. Because
Yeah.
the horizontal transformations are inside the function, the vertical ones are outside. And this mapping helps you to figure out that because h is really 1, so it's x minus 1, cube root of that, plus 2. Now you have a calculator on the test, you said. You can graph the one that you think it is and see if it looks reasonable on there, but you have to use the same window as this. That's maybe why your instructor chose this, because you can't just you'd have to be very careful to get it right. But I would just figure out what it moved and substitute its values. And there's a bunch of other variations on this problem. So yeah, gotta be careful here. I can't give them all to you. We would spend too much time.
Yeah.
Okay, so can we look at 9 next?
Yes.
I see that it's asterisks. So that maybe is one that was unclear. Okay, the transforms performed to f of x are as follows: horizontal stretch by a factor of 1/8. So I like to do these one at a time. So this first one here, you have it correct. It's the square root of 8x, like that. Okay, now the thing that is odd here is that you actually have to treat x like it's in parentheses, because your horizontal shifts go inside parentheses there. So it should be 8 parentheses x minus 3, like that. And this is not, it shouldn't say by a factor, it should say by just say shift of 3.
So how do you know if it's, so a shift is always going to be negative?
Well, it should say which direction. I'm assuming it's right.
Okay.
So this isn't written very well. But it because you stretch by a factor of, and I think it was just a copy and paste thing. That's probably why it came out. But the thing you need to keep in mind is that it goes in parentheses. Like the other correct answer here is the square root of 8x minus 24, but it's easier to write it in parentheses as x minus 3.
Right. Okay.
All right, so we do not have enough time to go through everything else. So why don't you pick the direction we go from here? Although some of this is stuff we covered in our last few lessons. Looks like maybe 15 and 16 are asterisked.
Yeah. Well, because I started them before, and then I went to office hours with my teacher, and then he kind of explained it. But so if it says f minus h, you just take the equation it already had plugged in, so like
Yes.
x 3 over 2, and then minus h, which is 5x 3 halves, and then you just combine like terms. So I think that's pretty
Yeah,
straightforward.
no, that's correct. It's very correct as it stands.
Mm-hmm. Can you do 14? I know how to solve them, but then I get confused on how to write the final answer with like the less than or equal to and like where to put everything.
Is there a reason you crossed out your answer in 14?
Yeah, I don't, because I looked on his answer key and he didn't have 48.5. He had the one that I boxed.
Okay.
Pretty sure that's the right answer.
Yeah, so this is yeah, so the what you did is correct.
Mm-hmm.
Okay, but there's this lingering, and we didn't talk about this last time, so we don't have enough time to talk about it. Sometimes I don't tell you the full information because it's like I don't want to get so into the details if you can't do it. This is true. The problem is that the square root of x has to be, the x part has to be greater than or equal to 0.
Yeah.
Okay, which means that like the inside part here, 2x plus 3, has to also be greater than or equal to 0.
Mm-hmm.
And the reason is because you can only take the square root of a positive number. So your answer here is correct. Like x needs to be less than 48.5. But think about, let's just say x is negative 10. 2 times negative 10 is negative 20, plus 3 is negative 17. You cannot take the square root of that number. So
Right.
there has to be a lower bound on this thing. And you get that by setting the inside part greater than or equal to 0 and solving for x.
Yeah.
So you divide by 2. So x has to be greater than or equal to negative 3 halves. That's really your domain.
So explain to me again why do you set it to 0?
Because because the square root of x, like its domain requires the inside part to be greater than or equal to 0.
Okay. So
And
no
so it's,
matter what you do, you set it to 0 every like equation that's like that.
yeah, we can do another one here real quick. Because it's really both parts. So what I was having you do last time was just the whole solving of this, but let's do another one like 14. Let's say it's the square root of 4x minus 3 less than or equal to 5. Okay, so you can solve it just the way you've been doing, square both sides. And then that gives you 4x minus 3 less than or equal to 25. Add 3 to both sides. 4x is less than or equal to 28. Divide by 4. So x is less than or equal to 7. But if you look on a number line, here's negative 7. There's a lot of numbers less than negative 7 that can make this root negative, the root.
Yeah.
And so that's where you have to also say, oh, 4x minus 3, the part inside has to be greater than or equal to 0.
Mm-hmm.
Now, what some instructors do, and I need to show you this last time, is they actually put it like right here. Did you see that in class, or did you always make it off to the right like this?
We kind of made it off to the right.
Okay, that's fine. So you add 3, 4x greater than or equal to 3, divide by 4, divide by 4. So x has to be greater than or equal to 3/4. Okay, so you come back to your number line. There's 3/4. I'm just making that up. And it's all the numbers in between. Between is okay.
Okay.
So in terms of how you write your answer, it's an inequality. It's 3/4, the left bound less than or equal to x, less than or equal to, sorry, this should be positive 7. Sorry for writing that. So the only thing you have been lacking or we didn't talk about and you didn't do in this problem is you have to set the inside part greater than or equal to 0.
Yeah. Okay.
So let's just do one more of these. So let's say it's a square root of 2x minus 1 greater than or equal to, I'm sorry, less than or equal to 3. Okay, so you start solving it the way we've done, 2x minus 1 less than or equal to 9. You add 1 to both sides, and then you get x less than or equal to 5. But then you also have to set the inside part greater than or equal to 0. And so you get 2x greater than or equal to 1, x greater than or equal to 1/2. And that's what we're saying here. We're saying that, like, okay, it's got to be greater than 1/2. But it also has to be less than 5. So where is the overlap? Well, the overlap is between those two numbers.
Right.
And that's why you say, oh, it's from 1/2 less than or equal to x less than or equal to 5.
Yeah. Okay, I get that now.
All right. Well, that does take us to the end of our lesson for tonight. You said your exam is tomorrow?
Yes.
Okay, we'll take a look at our notes, review the stuff that you're not confident on. The stuff you already know, you'll be fine. But it's always better to look at the stuff you don't know rather than hope it's not on there.
Yeah.
All right. Well, thanks, Isabel, for letting me help you. If I don't see you before Thanksgiving, hope you have a good holiday.
Thank you so much. You too.
All right. Have a great night. Bye now.
Bye.